So in this question, a person pushes horizontally to the right on a 200 newtons box on a frictionless level surface. So it is accelerating at a rate of 3 meters per second and we're trying to calculate the force applied on the object. So visualize the problem starting with the free body diagram for the box. And we have to specify the positive x direction, and applied force is acting along the positive x direction, and the weight is directly downwards. It's always directly downwards. And then the normal force is up because the surface is pushing on the object to the up. Also, look at the relative magnitude of the normal force and weight. They should be equal in magnitude because the object is accelerating in x direction, and the net force in y direction should be 0. Weight is equal to mg, and in the question, we have the weight, which is equal to 200 newtons. And if you want to calculate the mass, you have to divide that by 9.8 meters per second squared. And let's see whether this equation is dimensionally correct. For that, we should know the SI base unit of Newton is kilogram meters per second squared. And I'm going to show you 200 kilogram meters per second squared. Divide that by 9.8 meters per second squared. Meters per second squared will cancel out, and you get the unit of the mass. It is kilograms. And the unknown is the force applied, and it is acting to the right. So we have specified the coordinates: positive x, positive y. Positive x is to the right, positive y is up. And force applied as the unit newtons because it is a force, and the sign is positive because the acceleration is to the right, so net force should act to the right, and there's only one force acting on the object in x direction, that is the applied force. And this is Newton's second law, the concept, section 4.3. Now I'm going to plan a solution. Let's start with the chart. I'm going to look at each force, and then I'm going to find out the x and y component of each force. So let's look at the x and y component of each force. Force applied is acting to the right. So there's only x component for the force applied. It's positive. And y component is 0. And the next force is the normal force. Normal force is acting in y direction, so x component will become a 0, and then y component is positive because it's acting up, and then weight is acting downwards, so there's only a y component and it's negative. And now we are going to use Newton's second law. Net force is equal to mass times acceleration. And I'm going to use the component form of the Newton's second law because the object is accelerating to the right. So the net force in x direction is mass times acceleration in x direction. And now let's execute the plan. Net force is equal to mass times acceleration, and let's look at all the components of forces acting in x direction. So this question is very simple. You just have one force acting in the x direction, and mass is 20.4 kilograms times the acceleration is given in the question. So 3 meters per second squared, and you get 61.2 newtons. Again, this is the unit is newtons because kilogram meters per second squared is the SI base unit of newtons. So applied force is 61.2 newtons. And let's see. So we have the correct sign. In fact, we are actually interested in only the magnitude of the force applied. and it's in newtons and everything looks good. Now let's see the process. We visualized the problem. We started with the free body diagram, specified the x and y axis, positive x, positive y, and we paid attention to the relative magnitudes of the forces in the free body diagram. And since we have the weight, we calculated the mass using the weight, and then we made this chart and looked at the x and y component of each force, used the component form of the Newton's second law, and looked at the x components of the forces.